Okay, guys, welcome back to part 2 of our diagnostic test mathematics paper. If you have not yet looked at part 1, then go and check it out before coming back to this video. In the previous video, we looked at questions 1 to 30. We're now going to be looking at questions 31 to 60. All right, so let's start with the first question. A practice game lasts for 1 hour and 45 minutes. If the practice game began at 2 o'clock, what time did it end? Okay, so the game lasted for 1 hour and 45 minutes. All right, so what we would need to do is to add 1 hour to 2 o'clock. So from 2 o'clock, we will calculate another hour. That takes us to 3 o'clock, and then another 45 minutes. Okay, so that would take us to 3:45. Okay, what is 3:45? Based on the options here, which option gives us 3:45? 3:45 is the same as 15 minutes to 4 o'clock. So our answer is C. All right, and remember, guys, there are different ways to do the calculations. So you don't necessarily have to use my method, but just make sure that whatever you do, you're adding 1 hour 45 minutes. So we could have done 2. Okay, this is 2 o'clock. And then we add 1 hour 45, if you want to do it this way. And that gives us 5, 4, 3:45. Of course, like I said, 3:45 is not necessarily an option there in that format, but 15 minutes to 4 o'clock, that's the same as 3:45. Next, we will go to question 32. What time is shown on the clock? Okay, is it 25 minutes past 10? Is it 25 minutes past 11? Is it 10 minutes past 5? Remember that the shorthand usually points to the hour and the longhand points to the minutes, okay? So in this case, though, the 10, and I'm just doing this practically for those students, this is grade 3. So the shorthand has moved a little away from 10, but it's not yet at 11, okay? So when the clock moves 1 hour, it will go up to the next number. But in this case, we're still at 10 because it has not yet gone to 11. So it's now 25 minutes. Okay, so remember that at 10 o'clock, the long hand would have been pointing to the 12. And as we go around, there are 5-minute intervals for each number. So this would be 5, 10, 15, 20, 25. So it's 25 minutes past 10. Remember, guys, the shorthand is not yet at 11, so we are still in the hour of 10. Next question. And I hope I'm not going too fast for you guys. I hope I'm doing it at a speed that you guys can understand. Okay, so which of the following would be best measured in milliliters? All right, so remember we use liters for measuring liquid, but then in terms of how much liquid we're measuring, then what would be the appropriate unit? Would it be liters, milliliters, kiloliters? Okay, so milliliters are pretty much the smallest of measurement using liters. So we would not measure rice, of course. Remember, we said that the milliliters would be for liquid, and then of course that big jug of oil, millimeters would be too small of a unit for that. So milk, okay, the glass of milk, that could be measured in milliliters? Answer is A. Question 34. How much water is in the jug? Okay, so the jug itself can hold 1 liter of water. Okay, remember we said liter is for liquid, right? But the amount of water in the jug is not at full capacity. Okay, so if you notice, it's right here. Okay, this is where the water stops. Okay, so it's not quite at the capacity of 1 liter. So A could not be correct. It's not 1 liter. So what we need to do now is to figure out how many milliliters are actually in 1 liter. Okay, so would it be closer to 80 or 800? So it actually takes 1,000 milliliters to give you a liter. Okay, 1,000 milliliters to give you a meter. So since the jug is almost full, then it would take 800 milliliters. Okay, so this would be, looking at this, we have 1, 2, 3, 4, 5. So I'm going to assume that each measurement here, each line here would represent 200 milliliters. Okay, this would be 200. Try to use my finger. And then here would be 400. Here would be 600 milliliters. And of course, here would be 800. And then another 200 would take us to 1 liter. So the answer for this one would be C, 800 milliliters. Next, we go to question 35. The Smith family went on vacation for 22 days in the summer. About how many weeks were they on vacation? So we would, of course, need to know how many days make 1 week, and then be able to calculate how many weeks are in 22 days. So and as I said, guys, I try to make it as practical as possible for those who know how to do this. Then you can simply go ahead and divide 22 by 7. But for students who may not necessarily understand all of that, let's do it this way. So we have week 1 would be, what am I doing? All right, so for week 1, it would be 7 days, and then another 7 days. Let's see how much that is right now. That's 14. Okay, so this would be 1 week. 1 week. And this would be 2, okay? Another week, so that we are now at 2 weeks. Okay, so if we add another 7 days, okay, that would take us to 21. And so this would be the 3rd week, okay? So 21 days, that's 3 weeks. And then there's an extra day. So we are closer to, they went on vacation for practically 3 weeks, okay? It would not be 4 weeks because you would need another, they only have an extra day. So they're still at the 3-week mark, okay? Not 2 weeks. 2 weeks would be 14 days. Another week added, that's 3 weeks. So they were on weeks. This is about how many weeks? They were on vacation for about 3 weeks. The answer is B. Question 36. Which statement is true about 100 meters? Is it equal to 1 kilometer? Is it shorter than 1 kilometer? Or is it longer than 1 kilometer? Again, you guys have to know about the metric and how to convert from one unit to the other. So how many meters does it's in 1 kilometer, and it's actually 1,000. So 1,000 meters is equal to 1 kilometer. Okay, so is 100 meters equal to 1 kilometer? No. it is shorter than 1 kilometer, because you'd actually need 1,000 meters to give you 1 kilometer. So the answer is B. It is shorter than 1 kilometer. All right, question 37. What is the perimeter of the rectangle below? Now, again, guys, to do perimeter, we can do it in two ways. When we have regular shapes, we can use the formula. Okay, when you have a regular square or rectangle, we can use the formula, okay, for perimeter, that says perimeter is equal to length plus width times 2. Okay, that's the formula for perimeter. When we have irregular shapes, or even if the shape is not irregular, then we can simply add all the sides, the distance around the shape, that's the perimeter. So let's find out what the units are. They didn't give us the number, so we have to calculate, but they did give us a key, and the square represents 1 unit. So let's see how many units going across the top. 1, 2, 3, 4, 5, 6, 7. So there are 7 units going across the top. So again, that will be 7 at the bottom as well. And then there are 2 on the sides, okay? So we can simply add all the sides, or we can use a formula. All right, so the perimeter using the formula is equal to 7 plus 2 times 2. The perimeter is equal to 14 times 2. So the perimeter is 28. Okay, 14 times 2, that's 28. Or we could have added all the sides. So we could have said the perimeter is equal to 7 plus... I did something completely wrong. 7 plus 2 is 9. I don't know where I got 14 from. All right, so the perimeter is equal to 9 times 2. And you have to be careful of these mistakes, guys. You know, we just have to be careful, and that's why we have to recheck to make sure that we are doing the correct thing from time to time. So 7 plus 2 plus 7 plus 2, okay? So the perimeter is equal to 7 plus 2, that's 9. 9 plus 7, that's 16, plus 2 more, that's 18. So the perimeter is equal to 18. So you can do the addition, or you could have done it using the formula. Did I put the answer there? Let me see. Okay, so the answer is 18 units. That's the perimeter. All right, let's get to question 38. A rectangular flower garden has a perimeter of 24 meters. Which of the following could be the length and the width of the flower garden? So they gave us the perimeter. We now have to find out what the length is and what the width is, okay? So let me draw a rectangle. And remember what I said about the perimeter, mean the distance around. So if we should add whatever option we choose and we put the numbers in, we could simply add all around and it should give us. So let's try the first one. So if we put 9 here and 9 and 3 and 3, and we add all the sides, 9 plus 3, that's 12. 12 plus 9, that's 21. 21 plus 3, that's 24. Okay, so I already found my answer, but just to be on the safe side, let's check the others. Okay, let's do this again. So we have 6 and 4, 6 and 4. 6 plus 4, that's 10. Another 6 plus 4, that's 10 again. So this would have given us a perimeter of 20, and this would be incorrect. Okay, let's try the other one. 10, 10, 4, and 4. 10 plus 4, that's 14. and another 14, that's 28. So this would have given us a perimeter of 28, and that's also incorrect. The perimeter is 24, so our answer is A. Remember, guys, the perimeter is the distance around the shape, so you have to add all the sides. All right, so question 39. A pencil, a pen, and a screw were measured using pieces of centimeter rulers, as shown below. Use them to answer question 39. Which object is the longest? Is it the pencil, is it the pen, or the screw? All right, so let's take a look. Now, if you are going to be calculating or measuring, right, the length of each, okay? The pencil starts here and it ends here. Now, you might be tempted to look at the units here and see that it stops at 8 and that the screw stops at 6 and the pen stops at 10, and then try to, or assume that since the pen stops at 10 is the longest, but what we have to check is how many units it covered. So for the pens, it covered 1, 2, 3, 4, 5 units, okay? And for the pen, it covered 1, 2, 3, 4 units. And let's look at the screw. It started at the 3, ends at 6. It covered 1, 2, 3 units, okay? But remember, they're not all being measured from the same starting point. So which object is the longest? It would be the pencil because it covers 5 units. Not the pen because it stops at 10, but we have to check how many units it covers, and that's why the pencil is the longest. All right, question 40. What is the best estimate for the area of the pentagon shown below? Okay, so now this is a very irregular shape, and so we cannot use the regular formula for area, which would be length times width. What we have to do in instances like this, we are pretty much going to have to add up all of the possible units that would be covered by the pentagon. Okay, so there are some basic squares there, full squares, and then we have some partial squares. Okay, so we're going to see best how we can estimate what the entire area is. So 1 unit again is covered by 1 square. So what I'm going to do is pretty much count the units, and then those half units and partial other, units, we'll see how best we can combine them to make up 1 unit. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 perfect squares. So we already have 18. Now the others, we still have to account for them because they're part of the area. So what we're going to do is to try to estimate or group them to see how much more we would have. So far we have 18. The possible answers 15, 20, 23. So of course it would be 15 units because we've already passed that. So let's see how best we can combine. So these two could make up another one. So we're now at 19. All right, this would be 20. So we are at 20 and we still have some more to go. So it could not be B either. So this would be maybe 21. This could be 22, and this be 23. Okay, so I'm going to say the best estimate for the area would be 23 units squared. Okay, we don't use a regular formula for these irregular shapes. We simply have to count up the space that it takes up. Okay, so that's what the area is, the amount of surface space that it covers. All right, so question 41 is similar. What is the estimated area of the leaf below? So again, is it 168 square units, 53 square units, or 48? So we're going to have to do the same thing. And first, I like to add all the perfect squares and then I try to combine and see how best. So let's do that as quickly as possible. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, okay, 42, 43. All right, so what I'm going to be doing now is trying to combine some other units. I'm trying to get to, this would be 44, 45. Okay, so I'm going to try to start combining some of the half units now. 46, 47, 48. Okay, so we're at 48 and we still have some extras. So we know it couldn't be 48. And we definitely see that it can't be 168. We don't have enough for that. 48. Here's another one. 49. And this could be 50. Okay. And this is 51 here. And 52 here. And 53 here. Okay, so there are some little extra spaces around. So the best estimate would be 53. Sounds a bit tedious, but I mean, if that's what we have to do to get the job done, then that's what we have to do. All right, so you count up all the main squares first, and then you try to put the pieces together to see how much could actually get fit into one space. All right, question 42, it says examine. I might have to make this a little bit smaller. Okay, examine the pentagon below. Use it to answer questions 42 and 43. Which of the following is similar to the pentagon? Remember, pentagon has how many sides? 1, 2, 3, 4, 5 points, right? So it has 5. Now, which of the following is similar? So it could not be the triangle, okay, because that has 3 sides. This shape also has 1, 2, 3, 4. So the one that's similar to the pentagon would be 1, 2, 3, 4, 5. Another 5-sided figure for the pentagon. This one. Okay, the answer is C. Now it says which shape is made by joining STW. So let's look to see where STW is, and then you're going to determine which shape is made by joining. So STW, this is S, this is T, and this is W, okay? Which shape is made by joining these 3 points? And of course, that's pretty obvious, it's a triangle. So the answer would be A, triangle. All right, let's get to question 44. Which shape has one line of symmetry? All right, so what's a line of symmetry? You will have to know what that is first before you could go about answering. So when we cut a shape, a figure, a shape in half, okay, then we want, if we draw a line through a shape, then can we find that the 2 halves are the same, or like one side is the mirror image of the other side? So how many times or how many different ways can we cut this shape and possibly have more than one lines of symmetry? Okay, is it possible to cut these shapes in more than one ways and get different lines of symmetry? All right, but it says which shape has one line. Okay, so when we look at the triangle, how many different ways could we cut a triangle in half and have different possible lines of symmetry? Now, the only possible way to cut this triangle in half and have a line of symmetry would be this way. And so one side, mine is not very accurate, but if we should, both sides are symmetrical, meaning that they're the mirror image of the other. Now, if I had tried to cut it this way, then both sides would not be equal. That's not a line of symmetry for the triangle. So the triangle has only one line of symmetry. Now, for this shape, I could have cut it this way, and the two sides would be identical. Or, let me erase this line. If I cut it this way, they will still be symmetrical. So this has more than one lines of symmetry. As this looks like a square. So if I cut it this way, remember guys, my line is not very accurate, then it would be you would have two identical parts. And if I should cut it this way, it still has two identical parts. And I could even cut this diagonally since it's a square, and it would have two equal parts just the same. So the only shape that has one line of symmetry would be the triangle. It could only be cut in one way. Okay, so the answer is A. Remember, the line of symmetry divides the shape into two mirror images. All right, so question 45. Jack drew a picture on a piece of paper and folded it in half to get the picture below. Use it to answer question 45. Which shape is the other half of the picture? Okay. And of course, it's pretty obvious, right, that the other half of the picture is A. All right, pretty much where you folded the paper right here, we can see the same line here. All right, so that's A. The answer is A. Moving along, let's get to question 46. The pictograph, let me see if I can make this a little bit. Okay. All right, so the pictograph below shows 4 different types of cars parked in a parking lot. Use it to answer question 46. All right, so the key tells us that a car, okay, one of the cars represents 2 cars, okay? So the question says, which type of car has 2 times the number of cars that Mazda has? Let's find out how many cars first for each, and then we go into that. All right, so for the Toyota, there are 6 cars. Since each car represents 2, 2, 4, 6. For the Mazda, that's 4. Remember, each car represents 2. For the Nissan, 2, 4, 6. And now we see half of a car. That means this one represents 1 car, right? So half of the amount. So 2, 4, 6 plus 1, that's 7. And then the Honda, 2, 4, 6, 8. Okay, so it says which type of car has 2 times the number of cars the Mazda has? The Mazda has 4. So which car has 2 times 4? And that's Honda. The answer is A. Question 47. The table below shows the favorite ice cream flavor of some grade 3 students. Use it to answer question 47. All right, so we have chocolate, cookie and cream, strawberry, and rainbow. And then we have the tally marks. And I don't know, well, you guys should by now be exposed to tally marks, and so would know that this represents 5, okay? 4 strokes going down and 1 across, that's 5. Cookie and cream, that's 10. Okay, strawberry, that's 5, and then 4 strokes, 5. So 5 plus 4, that's 9. And then the rainbow is 5 plus 1, that's 6. How many students' favorite ice cream is strawberry? The answer is 9. So the answer is C, 9. All right, question 48. The graph below shows the number of students who chose one of 4 animals as their favorite pet. Use it to answer question 48. How many more students prefer dogs than fish? They didn't ask you how many students prefer dogs. They said how many more prefer dogs than fish. So we have to figure out how many like dogs. The answer is 7. right? Halfway between 6 and 8, that's 7. And how many like fish? Again, halfway between 2 and 4, that's 3. So how many more prefer dogs than fish? That would be 7 minus 3. The answer is 4. Okay, so you have four students who prefer 4 more students prefer dogs than fish. The answer is C, 4. Question 49, it says, examine the spinner below, use it to answer question 49. What is the probability of the arrow landing on a number less than 4 after spinning it? Okay, so we have 8 possibilities there because it's 8 numbers, so we have 8 possibilities. Now, how many numbers are less than 4? We have 3 numbers that's less than 4. So when you spin the spinner, right? When you spin the arrow, okay, then you would have 3 out of 8 chances, okay, of landing on because you could land on any of the numbers, but you have 3 out of 8 chances that it will land on a number that's less than 4. So the answer is A. Question 50, what is the value of the, I call that a sum in the mathematical sentence below? 12 plus that equals 23. So what can we add to 12 to give us 23? Okay. So another way to do this, we could subtract 12 from 23. And 3 take away 2, that's 1. 2 take away 1, that's 1. The answer is 11. So if we add, just to be sure, if we add 11 to 23, sorry, to 12, we end up with 23. So our answer is A. Guys, if you don't know what to do, you could simply insert each of the options, okay? So if it was B, you could check B, 12 plus 12, does that give you 23? Or it's 35 plus 12, does that give you 23? All right, so you could check it in that way to see if which answer is correct. All right, question 51. Which mathematical sentence should the number 5 be placed in the box to make it true? All right, so for this question, I think there was an error because when I did all the options, it could not be true if I put 5 in any of these boxes. Because if I put 5 minus 16, the answer is not 9. Okay, so this could not be correct. 16 minus 5, the answer is not 9. That's also not correct. 9 minus 5, the answer is not 5. So this is also not correct. I think they perhaps made an error. I'm thinking it probably would have been C, 9 minus 4. And then you would have put 5 in the box to make it true. But as I'm saying, as it stands, there's no correct answer there. So I am moving along. Question 52. Question 52. What is the missing number in the pattern below? Okay, so we have 20, 23, 26, blank, 20, 32, and then 35. Okay, so we have to look at the pattern. And if we notice what's going on with the pattern, the number is increasing by 3 each time. So when we add 3 to 20, it becomes 23. Add another 3, it becomes 26. So if we add 3 to 26, what's the answer? The answer is 29. And then if we add another 3 to 29, then of course it would be 32. So we're increasing by 3 each time. Question 53. In which of the following patterns is 18 the missing number? Okay, so in option A, 3, 6, 9, 12, in this pattern, we're adding 3 each time. So if we add 3 to 15, then this is 18. But let's look at the other possibilities. Okay, in B, 8, 4, 8, 12, 16, they're actually adding 4. So if we were to add 4 to 16, that would be 20. And in C, 11, 13, 15, 17, they're adding 2 each time. So if we add 2 to 17, the answer is 19. So the correct answer would be A. 6, 9, 12, 15, then 18. Question 54. Mary received 3 $100 notes, 4 $50 notes, and 3 $20 coins in change from the tuck shop. How much money did she receive? So 3 $100 notes would be 300. Okay. 4 $50 notes, that's 200. All right. And of course, you take your time to do your calculations. And then 3 $20 notes would be $60. Okay. So when we add up 300 plus 200 plus 60, we get a total of $560. So the answer is A. As I said, guys, you will take your time to do your calculations. For some of you, you may need to do the 100 plus 100 plus 100 plus 50 plus 50 plus 50. If you have to do it in that way, then do what you need to do to get your answer, okay? As long as you have time, then you do what you need to do to find your answer. All right, so Corey's father gave him the money shown below for his birthday. Use it to answer question 55. And of course, some of these monies were no longer, they're pretty much almost out of circulation right now, but we still can see the amount on each. So we should be able to identify how much money it is. All right, so 1,000 plus 500 plus 100 plus 50. So 1,000 plus 500, that's 1,500. Another $100, that's 1,600. Plus 50, that's 1,650. And for most of you, I'm assuming that you know how to count money. So it's 1,650. And of course, practically, you could do 1,500 plus 100 plus 50. Add them all together, and you would have gotten your answer. Okay, however you need to do it. Guys, like I said, do what you have to do. All right, question 56. Susie bought a bottle of water for $90, a snack for $50, and 2 pencils for $20 each. How much change should she receive from $500? And this is an example of a question that you have to make sure that you're reading the questions correctly, because you might just see all these and think that's what we should just add up all of these, and that's what they're trying to find out, how much we spend, but it says how much change. So first you have to add all that she spent and then subtract it from the 500 to see what her change was. So be careful, make sure you read your questions correctly. So 90 plus 50, all right, and then 2 pencils, 20 each. I'll separate them. Okay, add all of these. Okay, 9 plus 5, that's 14. 14 plus 2, that's 16. 16 plus 2, that's 18. So the answer is $180. She spent $180. How much change should she receive from 500? So we have 500 and we're going to subtract 180. Okay, 0 with 0 minus 0, that's 0. 0 minus 8, we cannot. So we have to go get a unit from here. This leaves 10. And now we have 10 minus 8, that's 2. 4 minus 1, that's 3. So the change you should receive from 500 is $320. Remember, guys, read the questions carefully. Okay? Questions, they're not very hard, but, there's sometimes a little bit of a trick, just to see if you're reading carefully. And so make sure you do that. All right, so question 57, almost at the end of the paper. Miss Pat bakes cupcakes for the school's tuck shop. Each baking tray can hold 1 dozen cupcakes. She wants to bake 48 cupcakes. How many trays of cupcakes will she need to bake? All right, so each baking tray can hold 1 dozen. Guys, if you don't know what 1 dozen is, then that's a problem. You guys have to know what these represent, okay? So 1 dozen is 12, okay? So again, this can be worked in different ways. So once we know that each can hold 12, we can simply try to add 12 and see how many different 12s we would need. Okay, so 12 plus another 12, that would be 2 trays, okay? So that's 24. All right, we're not at 48 yet. So that means we can add another 12. We're now at 36. Okay, so we can also add another 12. So far, we have added 3 12s. And let's try to do one more. We were at 36. We can add another 12. And that gives us 48. So we see that we have 4 12s, okay? So we can do 4 trays. All right, so again, since we said 12, we could have done, if you know your multiplication tables, so you could say 2 12s 24, 3 12s 36, 4 12s 48. That's another way to do it. All right, so you could have done it that way too. There's quite a number of ways that you could have used, methods that you could have used to get your answer. So just be creative, be smart, think about the question, and do your best to try to answer in your own way, okay? All right, so the answer was 4. How many trays of cupcakes? You would 4 times 12, that's 48. All right, question 58. Almost finished, guys. The capacity of container A is 500 milliliters, and the capacity of container B is 40 milliliters. About how many of container B would it take to fill container A? All right, so container B holds 40 milliliters, and container A has a capacity of 500 milliliters. So how many of container B can we use to fill container A? All right, let me make it smaller so we can see the options. All right, so is it 10? Is it 13? Is it 40? Okay, so again, this is a question that you would have to figure out how you are going to go about trying to solve this. All right, so one quick way, if you're thinking, we could simply multiply these numbers by 40. 10 times 40, 13 times 40, 40 times 40 to see which one brings us closest to 500 milliliters. All right, so let's try 40 times 10, okay? Okay. 1 times 0, 1 times 4. All right, that would be 400. 400 milliliters if we use 10. How about 13? All right, let's multiply. 3 times 0, 3 fours, 12. And then put our placeholder. 1 times 0 is 0. 1 times 4 is 4. Add these 2, 0, 2, 5. 520. So we would need 13. All right, 40 would be way too much because if 13 brought us over the 500, then there's no way we would need 40. So the correct answer, because if we did 400, we would still be able to pour more into it, okay? 2 and then some more. So we would need about 13 of the container B to fill container A. All right, let's move on. Question 59. The difference between the long side and short side of a rectangle, and you see this question has this paper has a lot of perimeter on it. The difference between the long side and short side of a rectangle is 4 centimeters. If the length of the short side is 3 centimeters, what is the perimeter of the rectangle? Let me draw a rectangle. And it says the difference between the long side and the short side is 4 centimeters. Okay. So we have the short side is 3 centimeters. What's the long side? So they say the difference between, so if we subtract 3 centimeters from the length of the longer side, we would end up with 4 centimeters. So of course, we simply add back that 4 centimeters to the 3 to give us the total. So the length, I'm going to put length here since that's what we're trying to find. So the length would equal 3 plus 4, okay? And so 3 plus 4 is equal to 7. And then we can prove if that is true, okay? If we subtract 4 from 7, then the answer is 3. So our length is 7 meters, okay? So what is the perimeter? So we have done finding the length of the longer side. Now we have to now find the perimeter. So we're not finished when we count the 7 centimeter. We have to now add up all the sides. And so 7 plus 3, that's 10. 10 plus 7, that's 17. 17 plus 3 more, that's 20. So the perimeter is 20 centimeters. Okay? Once again, let's just quickly again. The difference between the long side and short side of a rectangle is 4 centimeters. We don't know what the long side is, but when we subtract, okay, so when we subtract the 3 centimeters from the length, we ended up with 4, okay? So we don't know what that is. So of course, as I said, because we know that we subtracted 4 and we got a result, sorry, we subtracted 3 and we got a result of 4. And if we add those together, it would give us the total, which is 7. Hope that's a little bit clear for you guys. All right, so let's go to the final question. The weights of 3 objects, P, Q, and R, were compared using a balance. 2 comparisons were made as shown in the diagram below. Use this information and the diagram to answer question 60. All right, so in the first balance, we have P and Q, and based on what we're seeing, P is heavier than Q. When we compare P with R is heavier than P. So it says which object is the heaviest? Q couldn't be the heaviest because P is heavier than Q. And then P couldn't be the heaviest because R is heavier than P. So the answer would be C. R is the heaviest, okay? P was heavier than Q, but R is heavier than P. So R is the heaviest. All right, so there you have it. We are at the end of this paper. There's more content to come in other videos. And if you have not watched all the other videos as yet, please go and do so. Please share, subscribe, comment, and I'll see you in the next video.